Today on the bench we have an PSU 1600 watt PSU, fully modular. The previous owner says that it has been tested with paperclip, not turning on. No clue what's up. So let's take a look. Okay, let's see its packaging. It's pretty heavy, so that's definitely a powerful PSU. That's for sure. Got free envelope. Nice. I could use it. Sure, it's gonna come handy. Okay, it's fully modular, which I love. What? Didn't he say fully modular? Fully modular PSU. Is it 1600? It is. Well, let's call it a slight mistake. That kind of sucks. I was hoping this was fully modular. First of all, they're easier to sell. Second of all, they're easier to work with. You don't have to play with this bundle of cables always getting in the way. That sucks. I gotta see the listing again. That's not right. It's the graphics card. Yeah, but the picture definitely shows non-modular. Yeah. Let's see. Yeah. So it's consistent with the pictures. It's just, well, that's not good. Because this is not worth $50 when it's broken. Kinda sucks, so I'll probably reach out to the guy, maybe get a little bit of refund. Like $10 maybe. 30 by 40 bucks I can pay for this one if it's not fully modular, but for $50 broken, that's a bit much. Looks like it hasn't been opened. That's good. So we're the first ones to actually open it. Oh. Nice. Okay, that's not the right one, but this one's too big. Now, let's see this one. Even worse. This one also should be too small, but let's try it. Nope. And now the screw is damaged. That sucks. The easiest part, opening, and we already facing issues. Okay. That kind of sucks. What are you gonna do? Such is life. Let's see, maybe one. No, it's small. What is it? Okay, this one fits. Let's get and let's just put them here. And let's see this damaged one. It's still gonna work. Yeah. Okay. So I didn't break it that much, but I definitely did break it a little bit. Oh. Either too much coffee or not enough coffee. And I actually drink decaf, I don't drink caffeinated coffee. Okay, is this gonna budge? Okay, it will. Because sometimes you need to take off these 4 screws before you can remove the cover. Okay, and most likely, if it's not even turning on or anything, the fuse is going to be blown. Yeah, the fuse is blown, which means we have a short on the high voltage side, which is actually easier repaired than short on this side. Oh, and this side looks, this is like a completely different design than I'm used to. And there's only one transformer. There is a diode back. 5, 6, 7 diodes. Some of these must be something else than diodes. We have 3 beautiful transistors. Okay, crap load of filters and stuff removed. Capacitors, I mean removed, not installed from the factory. So this is kind of a cutting cost version. Let's see. Let's just quickly diagnose where the short is. It looks like it should be okay, and it's very clean. I think before selling it, the owner just blew it with compressed air, probably. But you know, let me just write do I have some labels? I need to get some labels. I don't really have anything to write on it. I only have black Sharpie, which is not gonna work on the black thing, but maybe here. What's the ticket number? Right here, UB2. I'm just gonna write UB2, and I'll find it. I don't want to later guess which one's to which, or I don't know, trying to fit them together, because I have 1 more and I have 3 more in the queue, so there's gonna be a lot of parts around. All right, let's these are big screws. Let's try this one. definitely some clip inside. Oh, here's one. There's one. And here's one more. Can I get to it? Not really. Maybe with this one. Even less really. This is a bit too small, it's not gonna catch it now. Do I have anything else? No. I don't want to damage the choke, but if I do damage it, I'll be able to fix it. There. Okay, just these 3 screws. Now, this guy. Okay, that goes through. That's the best way to desolder this guy. Okay, this one. This one. I could just desolder it from the board. Maybe I'll just leave the cables here because it's pretty much the same thing. And I'll be able to just remove the socket and just solder it outside so it's easier to test. But this one has almost no filters, no chokes, no capacitors, nothing over here. It just goes almost directly, well, not almost, it goes directly to the bridge rectifier here. So, you know, I test PSUs without those components, but you know, I just test them and then I put all those components back. And this one is just designed to work without those, so that's, well, actually it's designed to work with them, but they're not present, so that's a little bit worrying. Why would that be the case? But and let's get the UB2. Okay, that way I won't mix and match any parts. And now let's put this one to UB2. Okay. And there's one more screw over there hanging somewhere. I'll dig it out later. First I want to see what where the short is. This is output, this is input. And so this is, oh, okay. This has definitely been worked on. That I didn't expect. Felt like I was opening a completely new untouched device. Could it be that it came from factory like this? Yeah, there's on the cables. Yeah, there's crap load of unclean flux. Must be factory flux. That's weird, but if that's how it came from factory, that's fine by me. Okay, let's put it in the beep mode and see. Input of the rectifier is fine. The output is shorted. So output of the rectifier is shorted. So is it the rectifier? There's actually two of them. Is it the rectifier or is it one of the transistors? These are big. Now that's just capacitor charging, I guess. No, it's not capacitor charging. So this transistor, let's check this one. Not here, but here. 25 ohms. That's not dead short, that's for sure. Let's see. So this is ground, I assume. $25 ohms. And this one also. There's open line now. No, it doesn't say that it's shorted. And just a minute before it was. Okay, so that's a weird one. 25 ohms, that's a bit low, but maybe it's connected to the primary of the transformer, which would make absolute sense. These are main caps. Let's see the diode. The diode is showing voltage drop in both directions. This, so back voltage drop is still showing. Let's see the main caps. They very rarely go bad. Yeah, 600. And they're in parallel. Yeah, they're completely in parallel. And they are 330, and it was showing around 600. So these very rarely go bad. They do, but very rarely. Okay, so what is shorted here? Doesn't look like it's at the transistor, although I'll probably remove the transistor and just check it outside of circuit, because it's a bit bit too low. Yeah, 30, 12, 20 some ohms. And I don't see it going directly on the transformer. And there's some resistors here. Crap load of flux. Let's see the output. Let's see if we don't have any shorts on the output. Okay, that'll be quicker. So orange, that's 12 volts here, and let's catch the ground here. Open line. And it's the same thing. This is ground. 44 ohms. About 45 ohms. It is 1600, so it might have very low input resistance or output resistance. This is 2K on 5 volts. No, this is orange, so this might be 3.3. This should be, I assume red is it's 5 volts. Let's see red. Yeah, over kilo ohms. So that 12 volts. 45 ohm resistance is a bit low in my opinion. And 25 here, it's a bit low. But it's not a dead short, that's for sure. So I'm not gonna label it short just yet. I could just replace the fuse, which I need to do anyways. The fuse could have blown without the short if the power drawn was like excessively high. It's known to happen. What is that? Oh, that's 15 amp. 15 amp fuse. Yeah. Damn, that's a lot of power. That is a bit much. Not much for this PSU to just blow a fuse by itself. There must have been something that happened here. Let's get rid of all these. Oh, nasty. Let's see the diode packs over here. There should go from the outside in. That's pretty low. In both directions. it's not necessarily the diodes that are bad. But I need to take out the diodes because measuring, oh, this is something that I expect to see. Yeah, and in this direction. Well, in circuit, measuring these in circuit is a bit unreliable because they're almost directly on the transformer. But at least this is what I would like to do. So half of it. So this side looks to be functional. It's showing some relatively reasonable readings. So there's definitely something wrong here. So I'm not going to be replacing fuse just yet. I will just take off the entire heatsink with all these 2, 4, 6, 7. Damn, that's a lot. 7 diodes, if they're all diodes. But I see one over here that's oh. I don't know if these are diodes. I'm sure some of them are. Let's check these. Some of them have to be. Sorry. So let's see this one. Open line, which is expected. And here we have voltage drop. So this is definitely a diode. Oh. And on one side, it is a wire, not a diode. No? Oh, wrong thing. Yeah. Oh. Okay, I must have touched the wrong thing. Every time I measure, I get different measurements. Okay, this is a bit low. This is okay. And this is a bit low. So this diode might be... Okay, this one's good. And this is low. Maybe... let's see this one. So it looks like on the left side of those diodes, this is reverse polarity, shouldn't be like that. Yeah. So this, something wrong with this as well. Alright, that means that we're taking out, let's see, we're definitely taking this out along with all of these, and we'll see if that makes any change, any difference on the outside on the 12 volts. It's very likely 12 volts is a rail where you have the most the highest amperage, the most power. Most power from this guy is gonna come on the 12 volt rail. It should, let's see here. So on 12 volts we have 125 amps, 1500 watts. So only 130, the rest of the voltages, and negative 12, 3 watts and 5 FB, 12 volts, 12 watts. So if anything breaks, it's usually the 12 volts rail, which is consistent here with this weird reading on 12 volts. Okay, 30-minute 30-minute diagnosis is already too long, so I'm gonna cut the footage, do the boring stuff, and update you after I've done it. Alrighty, so I got the rectifiers and the main transistors and this little, I assume, diode that I actually took me a while because I didn't notice that little diode that was here. So I desoldered all this and it still wouldn't come out, and then I noticed that there's one more diode here. Anyways, after that removal, the short on the output is gone, and so I tested this guy, and it is 0, 0. It is a piece of wire. Well, all these are all good, and the rectifiers are all good. So this was the shorted component. That's what was causing, because it was right here. So this one over here, yeah, this is where the short was, but it was also everywhere else, so that's why it's kind of hard to diagnose it in circuit. So this component is let's get it under the scope. 60S50, which means 500 volts, 60 amps, and the other ones are 3050N, so N channel MOSFETs 3050. So this is the largest one, the 60 amps. But just replacing this guy, because I also checked the outside, so that 12 volt rail is still showing like 20. Right now it's showing 19 ohms. Still, I think it's a bit too low. Actually, it seems way too low. So my theory right now is that this transistor just burned because it tried to keep up the power for this shorted 12 volt line. So there's still something shorted over here. So my next step, after ordering that transistor, because I don't have that one in stock, will be to remove this heatsink along with all the components and see if the short is gone. If it is, then there's probably one of these diodes that is shorted. And from what I've seen, measuring in circuit, only half of the diode is gone. That's why the PSU was still trying to deliver power to actually suffice the power drawn, the current drawn on the output. So that is probably what broke this transistor, and this transistor caused the fuse to blow. That is the current hypothesis, and we'll see in the next step. Alrighty, so finally my transistors are here, because this has been sitting for a few weeks now, because I've been waiting for these, and unfortunately the only place that actually can deliver those is China, so that takes a while. Anyways, in this one we already diagnosed this transistor to be shorted, so I have a new one to replace, and the output capacitors obviously need to be replaced. I did a minor reverse engineering, meaning that I recognize this chip. It's a power chip controlling this little transformer which provides standby voltage. standby voltage on these, because this is the similar design as the other two I worked on, and I was unable to fix them. So with the relay switch over here that is controlled by the standby, and it turns it on when, well, obviously when you prompt it to turn on, but it'll turn on, check the voltages, and turn off if there's anything wrong. And so far 2 of these I was unable to fix. And this one also is similar in this regard. There's only 1 voltage coming here through these diodes, and through the main choke, and then it goes to 2 buck converters, one for 5 volts, the other one for 3.3 volts. So usually on these devices, let's get the box. So on these devices you get, let's see, 1600 is the main output, the overall power, 3.3, 5 and 12, so there's 1500 on 12, and 130 on these, so that doesn't add up. So usually it is 1600 output max power and 1600 on 12 volts, right? 125 amps here, because basically from those 12 volts these two are generated. So the maximum power is 1600, but it's divided by those three on those 3 voltages, or all the voltages basically coming out of the PSU. This one is not following that pattern directly, but I can see by the design that this is how it works. So all these caps will need to be replaced. This transistor, obviously the fuse. And now what could have caused this? My hope is that when the output capacitance went to 0, the PSU started generating, or PWM went way high, or duty cycle went way high to try to keep the voltage up on the output, and it was just too much, and it was connected to heavy load. So that is my hypothesis. The other possibility is the thunderstorm, but usually with these you see the actual physical damage on the transistors, like piece of the transistor physically blown, like a physical hole in the transistor, but not always. So that's pretty much it. Now I'm just gonna replace the transistor, replace the caps, and hopefully that'll fix the problem. If not, then it's gonna be the third one. Sorry, it's gonna be the third PSU of this design that I couldn't fix. Although I haven't really given up on the other two. I just need to get more familiar with this design. And without the actual schematic, it's kind of hard. Well, at least it's hard for me. I'm not exactly an electronics engineer. I'm a software engineer, so it's not exactly my profession. All right, let's get those replaced and see where we're at. If we have standby voltage, then that's at least good. If we can get it to emit the standby voltage, it'll be half of success, and the hard part will be to actually get it to run. The good thing about these little modules is that I can check them by connecting power directly to them and see if I'm getting 5 volts and 3.3 respectively. But probably these caps will also need to be replaced, which means I need to desolder this, because right now I have good access to it since I don't have these here, right? So I want to do it before I put the diodes back. and we'll see what it's gonna do. Alrighty, let's get to work. Alrighty, so now everything is soldered back in. I replaced the two, so these are the parts I replaced. So obviously fuse, 2 caps, and the transistor. Now I was thinking what could have caused the transistor to just blow up like this, just short like this. I started measuring, and on the main transformer I get like absolute 0. I was expecting, like at least like an ohm, 2 ohms, 3 ohms maybe. Obviously I expected low series resistance, but not 0, like dead short. So I was thinking perhaps this transformer just shorted inside, and that's what caused the transistor to blow up. So let's do this. I'll just connect the power, and if that is indeed the case, then the light bulb should lit up. The fuse, oh, that's probably when it turns on. Let's turn it on, hook up the power, and see if we have a standby. If there's no standby, we'll see. If there's no standby, I'll probably look around and see if I can figure out why there's no standby, but I will likely not be able to repair it. It's just too packed. So I was saying that this is the standby voltage, it is standby transformer, but there's one more that is very small. Now it's covered by the heatsink, but there's a very small transformer over there, so I think that's the standby. And next to it is the chip that likely is driving it. So let's get is this light bulb cable? It is. Okay, we don't want to mix those up. Let's do it. Okay, I heard the caps charging. Heard a little spark. Stay there. Let's see if we have a voltage on the rectifier, but I think it's okay. We have voltage on the rectifier. Now let's see PSU and standby. So standby is the purple wire. Let's catch some ground here. And standby, look at that, we have 5.10, so we have a proper standby voltage. The patient is alive. Okay, so now when prompted to start, if the transformer is indeed faulty, it should cause a light bulb to just light up, meaning there's just gonna be short. So either the transistor is gonna die right away, probably taking the fuse with it, or it's just gonna work. Okay, moment of truth. Okay, the light bulb is flashing, so it didn't catch a dead short now. There is no voltage, but we're working on a light bulb. Oh! Okay. PG. Okay, this is likely the fault of that were on the light bulb circuit. We have standby and if I move it, I think or is it a coincidence? I moved the plug and it turned on, but I don't think it's I think it's a coincidence. Yeah, it's going high and dropping, so it's likely because of the light bulb. Not enough current coming in to actually turn on the device. The relay, magnetic relay, did switch on, and basically it did boot. It did turn on. So now let's see on the unprotected circuit. That's charging. We gotta figure out a better way to do this, because this is rather annoying. Doing it this way, not to mention dangerous. Okay, now we have the loud spark. Okay, the fuse isn't blown. And the moment of truth. So now that's the good angle. Here is a good angle. So 12V2, I need to connect it through here, but first I gotta fix the plug, so it's plugged in with ground and everything. But looks like the patient is fully alive. I actually didn't have much hope for this one. So the 5 volts is at 5.1. It's acceptable, but I would expect 5.3. 12.3, 12.4, that is very good. 12.3 on V1. V2, actually let's see. Just connect V2. Okay, and V2 is 12.3. My camera's in a bad position. I can't really show you guys again. Maybe like this. I don't know if you can see, hopefully. So we got 12.3 on 12 volts, all 12 volt rails, so that's good. 3.3 is perfect. I would expect 3.4 actually. And 5.1, as long as it's above 5, it's good. 510 we already checked standby, and the turn on power good is after 280 milliseconds. So that's perfect. So now the best part, let's just put it all back together, put some load on it, and see the voltages drops. Alright, great news, I'm happy with this. Alrighty, so it's put together with the proper plug. I turned it on. I have the same voltages I had before, and actually one of the diodes was not soldered in. I missed it when I was soldering, and it was still working, so I'm guessing that confirms that there's 2 of them in parallel. I'm glad. Anyways, here is the load, and when I connect it, and I'll put the microphone over here so you can hear it nicely. And oops, when I connect this drive, it's an old hard disk. Okay, so this is what happens, and those sounds, they're not coming from the drive, they're coming, well, it's the same frequency, but they're coming from what I established so far, these two output buck converters here. Now, could this be the reason why the transistor burned? Could be. So I don't see anything other than capacitor being responsible for this, but I checked all of them here. I even desoldered one of these converters and checked caps on it. They were good, and only these two were bad. But well, these are measurements only, so it's hard to tell. But I can't replace these because I don't have the proper form, the proper package. Mine are a little wider, so first I need to order these and see if that helps. I even connected the scope to the 5-volt output, and these spikes that you can see over here, they don't seem like a lot, but actually peak to peak it's 6.6 volts. So that's a lot. So I'm thinking maybe the caps that I replaced, or the caps that I tested and they tested fine, are actually not fine when they're connected to load. That could be the explanation. I didn't check the smoothing caps on the primary side, which I'm going to do in a minute, because I was thinking maybe if the smoothing caps are gone, then now we're basically getting a signal instead of a steady voltage on the input. But I didn't really see anything like that on the output. I was expecting to see some form of, I don't know, 50 hertz. This one shows, right now it shows 1.5 kilohertz, which is actually, well, it's a high pitch, right? High frequency. So I don't think it's all the way out there, because you can barely hear signals at over a kilohertz, right? I think we can hear up to like 2 kilohertz as like the absolute barrier. You can't hear above that, so that would put it close to that range. It is high pitch, it is high frequency, I agree. So maybe that's if the oscilloscope registered that as a frequency, then that most likely that's what we hear. I'll check when with the recording I'm making right now. I'll check on the software, see if I can figure out what the actual frequency is. And actually, yeah, there should be an app too on the phone that you can install and measure the frequency. I'm gonna do that right now. Anyways, the PSU is working, but I think what we're hearing now is the cause of the failure that was then that eventually resulted in burned or shorted transistor. So I can leave it like that. If you have any ideas, well, I might be able to fix it before I release the video. But if I can't, then if you have any ideas, definitely let me know. Okay friends, it's time to give up on this one. As you can see, I already even tried to put some extra capacitance on the output to hear whether there's any difference, but there isn't. The only thing I know is that the noise is coming directly from the transformer, which is not surprising, although first I thought it was coming from these coils over here from the buck converters. That would have been a lot easier to figure out than the noise coming from the transformer. And the reason I'm giving up on this one is that the only way for me to actually isolate the problem is to replace the transformer. And because I believe that it perhaps got overheated. I don't see any signs of overheating, but you know, what do I know? Once it got overheated, the glue or whatever, epoxy or whatever is on those windings got loose, and now it started vibrating a bit, because the sound is proportional to the load you put on it, and it doesn't really matter which voltage, either 12 or 5, and because both are coming through this transformer. So maybe if I find another PSU that it has the same transformer in it, I'll replace it, but for now I'm giving up. I checked all the diodes, capacitors, everything, just blindly started checking stuff, like everything I could see. I just tested whether it's good or not. Everything tested good. So my final diagnosis is that the transformer needs to be replaced, and until I have one like this this one is just gonna be, well, technically completely working PSU. You can put the load on it, it's working just fine. It's just noisy. Well, anyways, I'll put this one back together. Too bad it's not ready to be sold, because this one would have sold easily, because it is 1600. But I can't with clear conscience. I cannot sell it to anyone, because I don't know how long is it gonna work making sounds like this. You know, it's not supposed to be making those sounds. But other than that, it's working well, so at least I'm happy with that. Too bad that I had to waste a perfectly good, expensive transistor on it. But luckily only 3 capacitors and 1 fuse, so that's not too bad. Alright guys, thank you very much for watching, and I'll see you in the next one.